Hello everyone, thanks for listening. My name is Bruce Hartpence and I'm from the Rochester Institute of Technology. This video corresponds to a paper called the Natural Selection in Virtualization Environments, a Decade of Lessons from Academia. There are actually 4 authors for this paper, myself, Sharon Mason, Daryl Johnson, and Bill Stackpole. Now to get us started here, I'll just mention briefly about our labs. We have several networking and systems administration labs, and the labs are much what you would expect in a computing environment. A lot of computers sitting on benches and a lot of racked and unracked equipment. And that's where we started long before we had virtualization. Our traditional model is that students would come into the labs, build something with the computers and the networking equipment, and then we would try to save their data. We ran the servers locally. Some servers were up at the campus level, and then the students had to interconnect everything via a network that they themselves would construct. In order to allow access to the servers and the devices, we had to create accounts. We had a couple of different kinds of accounts. We had accounts on servers that students would log into in order to save their data on the servers. But we also had local accounts on machines. But you can sort of imagine that as you're trying to run a lab environment, there are some management issues that sort of plagued us. One of them was students that had a lot of data. So we were constantly worrying about the size of the accounts and how much space we were going to allocate to an individual student. Once students save configuration data or files, lab reports, things like that, that's pretty straightforward. But what if we wanted students to build their own servers? Now, if the server is just software and they want to install a software program on our servers, that's one thing. But if they wanted to build their own operating system, install it from the ground up and then run their own server, for example, DNS or DHCP, they can't just run it on our server. We had to give them some kind of space to run their own servers and build their own machines. And this is where we ran into the problem of the bottom to top construction. They would install the OS, handle the packages, server software, and then eventually configure the server itself. So our solution at that time was to start imaging machines. So the idea was that a student would come in, set everything up on their own box, and then we would image the machine up to a server. The next time they came into the lab, they could pull the image down and reinstall the entire configuration on the fly. Imaging itself is a challenge because you're taking a picture of the entire hard drive or at least a partition. And there are several advances in the technology, but no matter what, you're still taking very large images of machines and saving up to a hardware server that you have at the front of the room, and then the students have to bring it back down, sometimes several hours later, sometimes a week later, but you had to store all of that information. Now the question becomes, where do you store all of those images? You could store it locally on the machine, but eventually you run out of hard drive space. Students lose their data. Students affect other students' data. We did try removable hard drives at one time. We ended up having really large servers and really large account space for individual students, and that was something that we had to manage. Imaging and re-imaging has some significant performance issues. You wind up worrying about the NICs that are in the machines, the backplane of the motherboard, read-write times on hard drives, and of course there's the simple transfer from the server down to the machines that you're doing the imaging on. When virtualization came around, it was sort of a candle to our darkness. It was one of the things that created a significant improvement in the way we were doing things. We could finally get away from imaging whole machines and some of the time constraints there. So the idea was that students would build virtual machines and run it inside VMware Workstation. And the nice thing was that you could run several virtual machines on one physical box. But virtual machines are also pretty big themselves. So when we're moving virtual machines around, we had some of the same issues that we did when we were imaging, namely storage and then moving things across the network. We still also had some choices to make. We had to decide where we were going to store software. And by this we mean things like Microsoft Office. We got into problems early on because the native operating system had Microsoft Office on it, and so did all the virtual machines. So we had this virtual machine size explosion. Did we want to make the students build the virtual machines, or were we going to provide them for them? So these were all questions that we had to answer along the way. And we'll talk a little bit more about some of these issues in a little bit. Over the course of the last several years, we've had a number of different virtualization flavors or models that we've worked with, and I've outlined them here. We have virtualization on the student machines, what we might call local virtualization. Virtualization in the commercial public cloud, and that is mostly Amazon. We've also done server virtualization with ESX, and we've built ESX clusters or ESX private clouds. And we'll talk a little bit more about each one of these as we go, but before we get started, let's go over some of the terms that we're going to be using. Two terms that are related to each other are local virtualization and server virtualization. In both cases, you have multiple virtual machines on the same piece of hardware or one physical device. In the case of local virtualization, this is where we're running a VMware workstation and we're spinning up a couple of virtual machines on that box. With server virtualization, we're using something like ESX or ESXi, and you're running a bunch of virtual machines on that piece of hardware and then accessing it via a console or a client of some kind. In both cases, you get an economy of scale. That is to say that you have several VMs running on one physical host, which is very handy. It reduces the number of physical boxes you have, reduces your management, and a virtual machine can be moved around where, in the event of hardware, the host operating system cannot be. Another side benefit of running in this particular environment is that students begin to understand something about virtualization and the issues associated with running multiple virtual machines on one physical platform. In the design parameters, we start to think about our scaling goals. Do you want to run 10 virtual machines or 20 virtual machines per host or per physical box? Server virtualization is also what we used to build our early generation private cloud. We call that RLIS. I'll talk a little bit more about that here in a second. Before I go on, one thing that's important to realize is that as the number of virtual machines on a particular box goes up, the amount of RAM and storage needed for that particular machine will also go up. All right, before we talk about public and private clouds, it might be good to talk a little bit about what cloud computing is. Cloud computing is a way of sharing resources and a way of spinning up or provisioning resources in a very short time frame. And what I've included here is the NIST definition for cloud computing. Cloud computing comes in really two flavors, private and public clouds. Public clouds are those that are given to a company by a provider. An example might be EC2 out at Amazon. Private clouds are those that you would run yourself. And really the big issues associated with public and private clouds revolve around ownership of the server and the services, ownership of the data, control of the data, security of the data, things of that sort. Now, the minute you go to virtualization, there are a number of stresses that you have to be concerned with. For example, virtualization, like voice over IP, is considered one of these disruptive technologies. That is, it's a significant departure from what you're doing currently. So if you're used to client servers, one-to-one virtual to physical hardware, then virtualization represents a step change from that. Faculty may not be familiar with the equipment, familiar with the issues. Staff may need some training. So there are some problems that go along with just simply adopting virtualization. Virtualization also becomes a resource that has to be managed, just like anything else. Virtual machines have to have storage. You have to have access to the virtual machines. There are some capital expenditures associated with moving to virtualization. And then, of course, once you're in a virtualized space, you have to keep up with industries. Once we start handling the issues, or once we decided to address them, we had some more decisions to make. How do you handle the storage of the data? How do you handle the software licensing, things like that? One of the first attempts we had was letting the students deal with their own data. The nice thing is that if a student has a laptop, they can install the virtual machines on their own equipment, and they have them. They can work on them any time of day. They don't need our lab space. We don't need to man the labs, things of that sort. There are licensing issues if you're going to give students virtual machines that have licensed software, or if you're going to give them access, then you have to sort of track who has what licenses and when. There are issues associated with requiring students to run their own machines, and these are pretty well documented in the literature. Can you require students to have laptops when they come into class? How do you make sure their software is up to date? Are you going to allow their machines to connect to your data? If a student loses their virtual machines, are you going to compensate them in terms of time, or is it just simply gone? And then what about the students that simply don't have the machines? In our case, we decided to provide the storage so the students did not have to worry about running virtual machines on their own laptops or their own desktops because we didn't want to deal with some of the issues. You can run virtualized spaces in a commercial public cloud. Some of the commercial public clouds, like Amazon, are free to students up to a certain point. Beyond that, sometimes there's a pay. If you're going to create a whole bunch of accounts, Amazon does have a pay-to-play model. The nice thing about the commercial public clouds is you don't have to manage it. You just have to set up accounts or ensure that students have the accounts. The accounts and the virtual machines are accessible 24/7, so it's very handy. But you do have to answer the questions about what happens when students reach the limits of the service, they run out of space, what happens in the event that Amazon or your commercial public cloud provider changes the way that they do things. What if they change their policies? Our next shot was the lab machine desktop virtualization, or what we might call local virtualization. And I outlined this earlier, but this is where we have several lab desktops that have VMware Workstation running on them, and students can run several virtual machines on them. They have to learn how to run VMware Workstation, learn what a VMware network is. The really nice thing about this is that initially we had 4 machines sitting on each one of our benches, and this really allowed us to go all the way down to 2. Sometimes we have to beef up the RAM in the machines, and we had to worry about storage space, but we did get some reduction in hardware, some reduced costs, and we weren't consuming as much power, at least on the lab benches. But again, faculty and staff had to learn how to run virtual machines in a VMware Workstation kind of environment. Coursework had to be rewritten so that in the case of our sample lab experiences, DNS clients and servers, DHCP clients and servers, coursework had to be rewritten to run in the VMware Workstation environment. We also had the problem of VM creep, or virtual machine creep, where the size of VMs grew and the number of VMs gradually grew. In fact, we're still battling the number of VMs that we have laying around. Following the local virtualization, we had a low-cost private cloud. So this was an award-winning private cloud built by our own Bill Stackpole and Charlie Border, called the Remote Laboratory Emulation System, or RLES. It was eventually built and based on ESX, and the idea was that several ESX nodes were built and students connected to it remotely and ran their virtual machines there. Very similar to the VMware Workstation model, although it was a more robust sort of model than that and centralized control. Toward the end of its life, the RLES private cloud, while it was very successful for what we wanted to do, started to run into compatibility issues, and one of the primary concerns at the time was virtual technology support from the hardware. As a result, we decided not to build another cloud. We migrated to a provider model. In our case, it was the campus network services were going to provide the virtualization environment. They had bigger hardware, they had more powerful hardware, authentication was tied to student campus accounts, and departments shared the cost of the system. On the downside, we lost control of the system, so we could not see the entire thing. The staff was not always available, and the system became, in some cases, very unresponsive, and we had performance issues with cloud. As a result, we've begun to rethink some of the decisions that led us to go with a campus-provided cloud. So where are we now? We have almost come full circle back to building our own relatively low-cost private clouds. Virtualization is becoming a more important aspect of systems administration and networking and security, and so we have built our own ESX nodes again, building them with off-the-shelf components. So we purchased the network equipment, the nodes themselves, and constructed a series of ESXi nodes for our own local use. And this is for classwork and for also some larger experimentation. So as my friend and colleague Bill Stackpole has just pointed out, the upside of running a low-cost private cloud is that we control it. The downside of running a low-cost private cloud is that we control it. So if things go wrong, we have to fix it. We have to make it work again. On the other hand, we don't have to worry about waiting for other folks or competing for shared resources. So what are we going to use the private cloud for in the future? We have a model for collaborating with other institutions via VPN access. So the idea is that we have the private cloud and we allow external access by other institutions into the private cloud for experimentation, collaboration, and in some cases, security competitions. So it allows us to expand some of our team-based student work with both local and remote teams. One of our other future endeavors is to create hands-on virtualization coursework. It's one thing to provide a coursework on virtualization and sort of explain the concepts. It's another thing to add virtualization into currently existing coursework. It is yet another to build a course where students get hands-on instruction into the construction of, the management of virtualization environments. Finally, one other possibility is that we collaborate with the very vendors that were helpful in the construction of the cluster itself. Well, that's about all the time we have. I thank you very much for listening and thank you very much for watching. If you have any questions, you can feel free to contact us at any time. And that is Bruce Hartpence, Sharon Mason, Bill Stackpole, and Daryl Johnson at RIT. Thanks very much.